All right, everyone. So today we focus on the job. It's 21st week. It's very quick. So let's review last week. What did we do first? Let's see. What's the last week? What did we do? Last week we focus on trinomial, right? Factor. Like this. So ax squared plus bx plus c equals 0. And find the solution. Factor.
I think I lost my notebook.
Oh no. And find the solution. Right? So all right, let's do some quick example. Let's starting here first. So first, take your notebook out. Let's quick do something. Quick quiz. First. You guys maybe remember this one you have ever done already in your homework. All right. So factor this one and find the solutions. All right. Do this one. Second, there's 3 of them. All right. Do that one first.
I also lost my notebook. It's not. I'm lost.
Let me see.
This kind of sauce. I think I know how to do it. Is it still recording?
Yes.
I can't find my notebook. Oh, it's not old. There's gonna be my okay. No, I just Is there more people on it?
Oh no. Let me see. Where I goes to? I lost my sharing screen.
I don't have the same pen, but like gigantic like.
Oh no. How can I make it share my list one? How to share my own screen now?
Sleep during class.
All right, finally. Okay, so you guys can find this one, right? You guys factor and find the solutions. And then second one. And the third one. All right, let's do 3 of them. It's a very typical example, like from the last week. All right, give you 2 more minutes, all right?
What's 3 times 27? The first one.
Yeah, Angela, you done? And let me check. Peter, can you see? Can you see what I'm writing on the board?
Peter.
Yes. Okay. Good. All right. Can you hear me clearly? Looks like yes, right? Because you respond to me. Huh?
Wait,
All right.
well, how do you know he can hear you if he's not responding?
He's-
Oh, he said yes.
Mhm.
He said to everyone. Oh my god. He said yes. Wow. But we can't see Peter. So how do I know who it is?
I know. Because they are all my students. So, all right. So everyone done, right?
Oh, what? No. No.
No. I'll give you 1 more minute, quickly. Because this is at your homework. So if you do your homework, you definitely can do this very quickly.
What if you didn't?
You didn't do homework, it means you didn't do. It will take a longer time to finish.
What if I almost got them all wrong?
Maybe there's a very possibility.
I was not.
Okay.
I think I know how to do it.
All right, let's begin now. So it's 10 minutes past. All right, so see this one. Let's see this one. Oh, someone just didn't come in. Can I see problem 3? Okay.
Uh-oh. Maybe you should come to class and then you can see. Huh. I can't see problem. What are factors of 81? 81. So.
Let's move on. Okay, so see this one. First question. So this one, we know this. We learn this one. How to factor, right? How to factor this one? Like this trinomial. Firstly, we need to find if they have the common factor first. Common factor. You can see 3, 30, 27. Definitely have their common factor 3, right?
Yeah.
And for x cubic, x power 2, x squared, x. So x at least is one of the common factor. So 3x is their common factor, right? So what's the rest? The rest is x squared, right? Minus 10x plus 9. So you got 0. Yeah, that's what we do last week. What we learned last week.
What?
Yes. So since 3x, this part can be further factored, right? So 9 can be factored into -1, -9. Got to pass together will be -10, right? So it means -9x, x. So here became a group, here became a group. What?
That's not what we did.
So it means x minus 9, x minus 1 equal 0. Right? So after that, so 3 numbers became 3 things, 3 expressions come together became 0. So we need to use our 0 factor theorem, right? So it means any of the factor E need at least one of the factor should be equal 0. So actually this is 3 is one of the factor. This one cannot be equal 0, but something unknown part. We can make x equal 0. Is 0 times anything else. Well, that doesn't matter what the other numbers. The whole expression will be 0, right? So you can make this x equal 0, or make this one become 0. Yeah, it can be this one became 0. So x could be 0. We say x2. The second question could be 1. The third solution could be 9. Right? Right? That's easy. That's good. So it means the first step, you need to factor it. The factor is the basic thing we need to do. And the second thing is let any of the factors be 0 and find the solutions. That's good. That's good enough, right? Jung, understand now?
I remember asking you that.
Yeah.
I think I did a different one.
You do it different way.
I think
You got the same solution. You use a different way. Yes, it doesn't matter.
this way is way easier than what we did last time. Yeah, like that little table. Like, what is that?
Yes, actually, this is actually we skipped a step already. We should use a little table.
No.
But okay, you prefer this way is even better because this is the best way, the quickest way to think about it. Yeah. All right. So let's stop this one. All right. Let's move on this one. So this one is based on trinomial. What about this one? This one, okay. Before I talk about this one, I need to give you a hint. All right. So we know that A cubic plus B cubic. This is called special product, right? Special product error we learned is can be factored into A plus B times plus B squared, right? I know this one a little bit long. You maybe don't remember so well.
I don't remember anything.
Okay, go back to a little bit earlier. We have ever do these kinds of divide. Do you still remember what's this divide?
No.
Oh, you can do plus. Did you still remember do this divide?
The only thing I remember was from last week.
This one is equals to, right? So it's reverse back, both part times x plus 1, so we'll be back. So we'll be, okay, so I'm going to write a little bit higher here, over the scope here, x plus 1 equal, we ever do this one? We use the polynomial division. We talked about this one, right? Angela, right? Grace, did we talk about this one?
Like, were we like 6 weeks ago?
Yes, long time ago. So it means we repeat talking about this one many times, so many times already, right? And actually we can extend it a little bit more.
Oh yeah, I remember that one.
All right, so you can remember now? All right, I know this one a little bit higher. Maybe someone, oh, they can still see that. That's good. So this is the common part. So we also have another one. The difference between two number cubics can be changed into like this, right? This became B squared. So this is the part. This is the part what we talked about earlier. But a long time ago, we keep repeating many times. So, okay, so go back here. So like this one, we needed to remember we use these kinds of formula actually. So this one can be rewritten into 2x power 3, right? 3 power 3 equals 0. Did you remember this one now? 2 times 2 equals 8, right? Yeah.
Oh yeah.
All right, you remember 2 times power 3 is equal 8 now.
Powers are too confusing. So are squares. Like, how am I supposed to use that?
All right. So this one means exactly match here, right? We can use this formula, this equation. So it means A equal 2x, B equal 3, right? All right, let's replace this part. So A replaced by 2x, B replaced by 3. So it became what? 2x plus 3. And this one became 4x squared minus 6x plus 9 equals 0. Got it? So it means this one can be factored into like this. So what next step? We do the same. We make it 0 factor thing. So it means we set each of the factor became 0. We need to at least one of these factor became 0. We can find their product is 0, right? All right, so we make this product become 0. So x equal what? -3 over 2. That's good enough. What about this one? Is this one can be 0? Is this one can be further factored?
Yeah. No. Yes. It's a trinomial.
Yeah, doesn't mean trinomial can all be factored. You need to double check. All right, so let me give you a hint here earlier. We will talk about this one. Actually, this one cannot be factored. Actually, this one never have an answer. X can make it become 0. This kinds of expression we call prime.
Oh, it's
Polynomial.
Just like the ones that you can only time by yourself.
All right, prime polynomials can further be factored.
Yes.
How we judge these kinds of expression is prime polynomials. We will talk about later, next week, several weeks later. Yeah, several weeks later, we will talk about this one. But I can give you a quick kind of talk about here first. I just try to ask you a little bit later. Something like these kinds of expression, when their never can be 0, or we call it their prime number, there's a criteria we call delta. This delta means b squared minus 4ac. This one is less than 0. They will cannot be further factored. All right, let's check this one. So this one, a equal 4, b equal -6, c equal 9. So it means -6 squared minus 4 times 4 times 9 equal what? This is 16 times 9, 144, right? 36 over 144. This one is equal -108. It's less than 0. So that's why this one cannot be further factored. So if this number becomes less than, so you don't necessarily remember this one right now. You only remember is this is called prime number. Prime polynomial cannot be further factored. You cannot find any answers out of here. Make this factor become 0. All right. So you can get this one. All right. So this is the methods we base on factor and got a solution. Since this is only one terms have the unknown part, and we can use the other methods to do it. All right. Second methods. So you can use move say ax power 3 equal -27. Right? So you can x power 3 equal -27 over 8. And this one can be rewritten into -3 over 2 power 3. Right? So it means x only equal this one. See, you can see this is the same, right? That's why they have only one answer here. They didn't have any actual answer because there's no answer for this one. So this one is way much easier than this one, right?
Then why do we learn that one?
Because 我们在上网课了，
有几个挺好，我就看到
我们上节课已经上了。
哦，你还培训就开始了？
没有，我上节课已经就开始用过了。
你现在这个多少人？
现在这节课相对少一点，
有几个在我们？
刚才有大概有10个左右。
10个左右。
对，这节课只有1个。
你在 Zoom 上？
因为两个 Angela 的爸爸，还有一个人加入了。
你现在 Zoom 上是吧？
对。哎，这个钟好像用了不限时间40分钟，我用了1个半小时。
你现在不对，你这个是咋的？这个是文字。
没有啊，我看了那个人呢，我看了我学生的那个视频，是正对的。
他们的文字，
咱们自己看是反的，咱们自己看是反的。 但是正面看它那个
啊那
log in 的话是正面，
那你自己也把它反过来，你把它反过来，
不用反过来，
不要反过来，
哎，能反过来吗？
还可以没有正常吗？
哎，不怎么正常？
你看，告
Wait,
诉
can we see that?
呀，
Wow.
对啊，
How do we learn the hard version if there's an easier version?
什么叫对不对？
That one and that one.
啊
OK，
，OK，
哦 OK，哦 ，That's better. Thank you. 谢谢。
对，这样就是将来的。
啊，对，我说我自己缓不过来，但是我认为我的刚才的学生，我让课上有个小孩拿了 iPad 为了 log in，他就可以。
对，这样你定了，对，可以了，对，好，
对，
这样他们应该还是 accept 的，基本上还是
对
accept
对，但是下周开始的
You
我
can't
家里嘛，
hear.
我就
You
外
can't
报
hear. You can't hear. You can't hear.
Can I hear？
啊，他没有 accept 的啊，
不对吧？Can
呃，
I hear？ Can I hear problem 3？ Oh no。啊，problem 3还没解决呢。啊 ，cannot see number，cannot see那 problem 3，
哦，C 的是
应该可以吧？应该可以吧？
对，
应该可以吧？
哎，这里可能
这个好多人写的
大一点，是吧？
对，这个都能听得见啊，应该能听得
Now
见。
can you hear? Can you hear us? Oh, there's lots of people.
Yes。
This is
啊，不
Angela.
对不对不对
This is
，Angela
Angela. Say hi.
Angela's daddy there。
You guys look at
Ah,
me.
maybe. 不对呀。
Girls, look at me. Girls, look
那
at me.
那我弄大声一点，应该能。
Sorry.
Can you guys, everyone can hear me？
啊，
这个不知道谁教的。
Who's Jilu?
Change your name, please. Add your name to your own name.
Who's Jilu?
刘哲就是 Peter's parents.
Oh,
One more time here.
I still don't know who Peter is. And who's Queenie's iPad?
强是 iPad. I don't know who, but anyway.
You can't-
I send out the password. They can log in. If they don't have password, they should be
Wait, so
see
you can just go to Chinese school on this thing?
Yes. All right. Let's.
不打扰。
咱们就 5 minutes temporary break first.
Okay.
5 minutes temporary
Bye
break.
bye.
你现在是 40 minutes second.
All right, let's see number 3 now. So we finished number 2, all right? So you can use 2 methods. The methods is the quickest way. Yes, that's the best method. And this one is general methods, all right? These general methods, traditional methods. If you cannot find this way, find a solution, this is another way to find a solution, all right? Like this one, you definitely cannot use these methods to get solutions. You have to use the factor methods, right? All right, so see the number 3. See the number 3 now. So this one is also another special product, polynomial special product. You guys still know 2 terms, sum of 2 terms, and difference of 2 terms. Their product is a squared plus b and minus b squared, right? Right. All right. So in these cases, we will take advantage of this formula. Okay. Let me double check here. Yeah. All right. So this one, you can see, you can do backward. So any numbers, if any square, the 2 terms square minus another term square, this can be factored into what? A plus b. Okay, into the terms, sum of the 2 terms and difference of the 2 terms. Product. So it means we can want to see what's going on here. So this one means we can rewrite it into any number can be rewritten into 1 square, right? 1 can be rewritten into 1 square. So in this case, this means can be used this formula is plus 1, the difference of these 2, right? Got it? So did this one factor completely? Is this one can be further factored?
No.
This one is called, this is point number now, point polynomial, right? So This cannot, I'm sorry, this one cannot call prime. They cannot be further factored. But what about this one? This one can still be rewritten into 2x squared minus 1 squared. Right, June? Is it correct?
Wait, then why can't the other one be 2x squared plus 1?
Yeah, so this is from here and here. One of term here, two terms of the sum of these two terms, and the difference of these two terms. Right? So this one cannot be further factored. We call prime polynomial. But what about this one? This one actually is the second step. Actually, like 4x squared can be written 2x squared. Right? So it means this part can be still rewritten into 2x plus 1, 2x minus 1. So all right, this part copy down here. All right, so make this one become 0. Let me see. Oh my God, oh no, I need to move a little bit further, sorry. This one right now is a little bit different. Move this a little bit back here.
Instead of using a computer, why not just use the camera?
Huh?
Instead of using a computer, why
I'm sorry right now. Thank you. Sorry for that. Right now, just move the computer a little bit away from there. All right. So let me repeat it one more time, since right now someone didn't see the board here, whiteboard here. So this one actually we take advantage of these polynomial products. So firstly, it can be rewritten into 4x squared, each self power square, and minus 1 square. So we take the advantage of this formula again to rewrite this one. And this factor cannot be further factored. We call prime polynomial. And this one can be further factored. Still can be rewritten into 2x power of 2 and minus 1 square. So after that, so finally completely factor into like this. So we still use the 0 factor theme methods. So at least need to make sure one of the factor be 0. All right, so if we make this factor become 0, yes, x can be equal half, right? So if make this factor become 0, x would be 1 over 2. Is this factor can be 0?
No.
That's not. Why? Because of, June, you come on.
Because it's prime.
It's not only prime. It's because you can see that when x squared is a number, it's a positive number, right? 4 times a positive number is always positive. If you even x is 0, 4 times 0 is 0. 0 plus 1, it means this point factor always greater or equal 1, right? They are never can be 0. So let's even any number put it right here. This one always greater or equal 1, right? There's no, you cannot make this prime polynomial become 0. So only have 2 answers up to now here. All right, just like what are we saying here, we use the factor methods, we can get the answer is 2 of them. One is the negative half and the other one is positive half. So if actually use your general method, the other one is say, why not we, since lost only one term is unknown, why we not use these methods? Yes, we can do that. You can see this one equal what? We can transform this one. And this one can become positive or negative half power of 4. Okay, so you can x equal positive or negative half. Is they are the same? They are the same. Right? Is it good? Okay. All right. So we use the 3 examples. Try to explain what last week what we learned. Actually, last week we also learned try to solve the real problem, right? How to build this equation. You still remember the rocket example and the throw ball example from the high tower, throw the ball from the top to the ground. Understanding? Okay, well, let's bring one example here. Let me pull this out. Let's do one more time. Let me share one of the screen here. All right, let me bring one of the all right. Did you guys still have your homework with you? Maybe we can use your our homework one to share. Did you guys still have homework? Take your homework with you, because I try to share online to everyone, but I cannot share with you guys because you guys don't have one with you. Just see the homework part. Let me bring the homework, pull the homework stuff out first. Oh, hopefully I didn't close everything. Okay. All right, everyone, can you see my screen now? I don't know if I can see. Okay, let's see the number 65. Can you guys take your homework? Do you bring your homework with you? Grace, do you still have your homework? You can bring this back to you first. Oh, this one doesn't have name yet. Okay. See the back side of the homework. See the 60. Let's see the 65. 65. I think 65 we already talked about it, right? Yeah. Let's bring another one. Just Michelle, do you want to
66?
66? Okay, let's see 66.
Can I read it?
All right, please. That's very great. All right, read 66.
An architect's squaring instrument is in the shape of a right triangle. Find the length of the long leg of the right triangle in the hypotenuse in 8 centimeters longer than the long leg, and the short leg is 8 centimeters shorter than the long leg. What? They already said that.
Okay, can you read it one more time? Can you read it one more time? Mm-hmm.
Okay. An architect's squaring instrument is in the shape of a right triangle. Find the length of the long leg of the right triangle if the hypotenuse is 8 centimeters longer than the long leg, and the short leg is 8 centimeters shorter than the long leg. I don't know what a long and a short leg is.
It's hypotenuse. Yeah.
What's a hypotenuse?
Hypotenuse.
What's a hypotenuse?
Okay. All right. So let's read it. Let's see the board here. I mean, I need to transfer the shares. Let me take this picture first, all right? Before I erase this part off. I know let's need to change. Okay. So the question is, I need to transfer this one to the whiteboard. Oh. How can I transfer into the?
The majority of class is still on review. We're still on review inside the majority of the class.
Okay.
We haven't
So
started
go.
the lesson.
Okay, let's see here. Let's see here. So the question is, you have the right triangle, right? Right triangle. Is it correct? June, right?
Yeah.
One of the side,
The long leg
the long leg.
is 8 centimeters long than the short.
No.
And the
So-
shorter leg.
No.
No.
Is it? Yeah, it is.
This side is
Oh, it's the hypotenuse.
A.
Hypotenuse.
If you don't know this one, say this side, one of the long leg. You don't know, right?
Wait, the 8 plus 8
And this side is 8
is
feet
the X plus
longer.
8. Is that the hypotenuse?
And this,
Hypotenuse.
yeah, and this side is, the longer egg is 8 feet longer than the shorter one. Shorter leg.
Wait, what's the hypotenuse?
Yeah, so first you need to make the relationship of these three first, right? You need to understand what they're talking. 66. Can you read it one more time, June? The length of
The length of what?
the long leg
Oh,
of the
the,
right triangle. Can you see one more time? Can you read it one more time quickly?
the whole thing? Yes, go. An architect's square instrument is in the shape of a right triangle. Find the length of the long leg of the right triangle if the, I don't know how to say that, is 8 centimeters longer than the long leg, and the short leg is 8 centimeters shorter than the long.
Yep. So you need to understand clearly each what they talking about. A right triangle, the long leg of this triangle is 8 centimeters longer than the shorter one. So it means the other one is x minus 8, right? And the other side is 8 centimeters than the long leg. So right now you build a relationship of these three sides. So you guys know that earlier say, if this side is A, this side is B, and the third longest side is C, the relationship is of length is A squared plus B squared equal C squared, right? Is it correct? So it means ax squared plus x minus a squared equal x plus 8 squared. So you need to build these kinds of relationship. Build the equations, right? So after that, you simplify it, all right? So here it becomes 16x, here it becomes 64, and the right side became the, you got this part. So move all the degree of 2 together to the left side, right? And this part is the degree of 1, right? And the third part, they are the same, became 0. So we can got it here. Is it right? So we can factor this one right now. The common factor is x. So we try to find a solution of these two factors. So your x can be 0. So first answer is x can be 0, or x can be 32. So let's check both of them, each of them separately. If the x equals 0, it means this length is 0. Is it possible? So if they are 0, it means not make any triangle, right? So this is not real. It's not very possible, right? It's not possible. So this part is x equals 32. Yeah, it makes sense. This is 32. So this one would be 24, and this one would be 40. Right? So this side will be 32, 24, 40. You got it? All right, let's take a real 5 minutes kind of break. Yay. And come back. And then we move on to new section part. Today we talk about new section, rational expression. All right, Grace, give me your homework now. Everyone give me your homework. Michelle, do you understand now?
Yeah.
Good.
Majority of class has been spent on trying to figure out the video thing.
Yes. It's very lot of time on video, so that's why we need to try to
Isn't it week 20 homework?
huh?
It's the week 20 homework.
Uh-huh.
Oh, wasn't there an online version?
Yes, I will send out online one.
I did the online versions.
Good.
And I was number 1. Yay.
Yep. All right. Did I give you this one?
Week 21.
Yes.
Yeah, no.
No. Let me pause here first.